Good morning, everyone. Today we are here to discuss the third term test paper that is given to you by the Western Province. Right? To be honest, this paper is much easier, and that is not in the standard what is expected in the final exam. But so I'm not going to discuss all the questions. I gave you all the answers. So let's jump into these 5 questions. Right? There are a few points that I need to address. Okay. First of all, question number 18. This is from Unit 9. Okay. Uh, you should be able to recognize these symbols. That is for a thermistor, and this is for a variable resistor. Okay. So read the question. Okay. So it says um, the resistor here is adjusted such that the LED is switched off, right? So there you have a voltage divider circuit. Okay, so this you can ignore this current. The base current is very small, that is in microampere range, and this current is in milliampere range. So you can ignore that part. That means you can consider these two resistors are connected as series. Okay, so if you increase the resistance here, that means the voltage increases. That will give you a boost in here, VBE, and that will also increase with that. Okay, so the transistor can be operated in 3 regions. Here in as a switch, we have cutoff mode and saturation mode, right? So once, if that is very low, the voltage here, that is in cutoff mode, right? If it is significant, then it will be moved to saturation mode, right? We don't put the transistor in middle, right? Not in active mode. You already know the theory. So see, the resistor is adjusted until the LED is switched off. Right? So it changes from switch on to switched off. So how can do that? The way is you can reduce the resistance here. So once you reduce the resistance, the voltage drops. So that the LED will moves on to saturation to cutoff. Okay. So after that, the temperature of the thermistor is now increased. Right? Now, this thermistor has this quality. The resistance of the thermistor decreases as the temperature increases. Right? So there are two types of thermistors, and this has a negative gradient. That means once you increase the temperature, the resistance decreases. Right? It's very understandable. So the materials inside this thermistor should be some semiconductor materials, okay? Because we know that property in semiconductors, when you increase the temperature, so the holes and electron pairs will be generated, right? So that way the conductivity of the material will be increased, so the resistivity decreased, right? Um, so you understand that. So anyway, once the temperature is increased, what would happen is the resistance decreases, the voltage decrease. That means there is a boost in this voltage, right? So that will drive this transistor from cutoff to saturation. Okay, so that means now see, you have to select the best answer. Voltage across the thermistor will be decreased, and the voltage across the variable resistor, that will be increased, and that will lead into LED to turned on. Okay, I hope you understand the theory with this thermistor part, right? That's what I want to discuss. Okay, the next we have question number 19. Okay, now the thing is there is no valid answer. As you can see, both resistors are short circuited with this line. So that means the resistance here should be 0. So 0 plus 12, the answer should be 0. So answer should be 12. That is not in the answers. Okay, so we have to change. Straightforward. So 32. Okay, there's one more thing. So if you're a single medium student, the answers may be not aligned with your paper because there are some mismatches with the two papers, right? English medium and single medium. So some data is changed in this paper, right? So just don't just follow the answers. This is only for English medium paper. It's 32. 32 also, it's not that difficult. You have to understand this symbol. That is for a fuse, okay? So normally we have this symbol for fuses. We normally use this symbol, and this is also valid, right? That's what I wanted to uh, discuss with you. Okay, next we have 42, question number 42. Okay, now this is a good question 42 years. The problem is there's some data is missing. Okay, just read the question. Okay, the half-life of a radioactive source is 64 years. That's a very long period. That means we are discussing 42 t half. That is 64 years, right? And let's change this value that in 2 hours, the time is given in 2 hours, the number of disintegrations, um, that should be this value 1.44 into 10 to the power 8, right? You need that data, right? Now that amount of disintegrations happen in 2 hours. You're asking what is the activity of the source. Activity also changes with time. This is referring to the initial activity of the source. Okay, so we know when we consider the graph, here you have activity and width versus time, and you have an initial activity, let's say a naught, and the time taken to become that half of that value is the half life, that is 64 years, right? It takes 64 years to jump in to half of that value, right? This value is 64 years. Now we are talking about only 2 hours time period, right? So 2 hours mean if you zoom in, it's almost like this part for 2 hours, right? It's like it's a flat line. Okay, so that means you have like almost constant uh, constant activity during that 2 hour period. So that way we can find the average activity, right? So average activity, that is number of disintegrations per unit time. That is what is activity means. So 1.44 10 to the power 8 divided by 2 times 3600 seconds, right? So this will give you the first answer, to in 10 to the power 4 becquerel, right? So that is the expected answer. But this is the average activity, right? So as I told you, this value is almost the same, right? So you have the constant activity during that time. So that way, what is the initial activity of the source? That means you can use this value, right? So that is the clarification for 42. That's a good question. Some data was missing. Okay, question number 50. I only selected 50 just to get a closure to this discussion, right? It's not a difficult question. Um, right. So don't fall into the trap thinking that this is the standard of the final paper. This is not, right? It's not even close. Okay. For some reason, they've given to you this paper. Okay. In this case, it's asking after 5 minutes, the substance is, right? There's a phase change. This part that is solid to liquid phase change during this time period. And here that is liquid to gas. Okay. So after 5 minutes means somewhere here, you have pure solid, pure liquid, and pure gas. So in between, you have a mixture of solid and liquid. Okay, now that's all we have to discuss, right? So follow these answers, and if you have any problems, just let me know, right? I'll catch you in the next video.